guys, welcome to this lovely session of Louis Tibet Engineering. Today, guys, we'll be doing electrotechnics and 4. Please do like and subscribe to the channel. So the first topic we'll be doing is the principles of electricity. That is what I'll be covering during that is the series of videos that I'll be doing, which is the first topic, the principle of electricity. But today we'll be starting with introduction to electricity. Okay, so basically what this chapter is about is telling you what electricity is. Okay, so guys, before we understand, we answer that question now, we have to look at the structure of matter. Okay, the structure of matter. Okay, we know even from high school, okay, guys, that matter is anything that occupies space and has mass. Okay, and because we studied this topic in electricity, because electricity is occurring at an atomic level, so that is why we cannot see electricity, but we can only experience or see its effect. Okay, for example, light. Electricity can produce light. Electricity can produce motion. Electricity can produce sound, or electricity can produce heat. We can only see its effect, but we cannot see electricity. Okay, we know that matter is anything that occupies space and has mass. Nah? Okay, so basically anything, even myself, I am matter. Okay, even this board is matter. Okay, matter, guys, the smallest particle of matter, we call it a what? An atom. Okay, that is the smallest particle of matter. Okay, so we know an atom from N3, N1. An atom, there is a place in an atom that we call the what? The nucleus. Nucleus. Okay, and guys, inside the nucleus there is a positive proton, and then there is a neutral neutrons. Okay, so I'm just putting two protons there. There is positive protons inside the nucleus and neutral neutrons. Okay, then rotating in orbit around the nucleus of an atom are what we call electrons. Okay, we know that electrons, guys, they have a negative charge. Okay, for an atom to be electrically neutral, okay, there must be an equal number of positive protons and an equal number of negative neutrons. That means the atom is what? Neutral. So the resultant charge of the atom is what? 0. So positive and negative will balance each other out. Okay, but the atom is not always in a neutral state. For example, we can remove an electron, okay, through a process that we refer to as ionization. If an atom is removed, if an electron is removed from the atom, we see that there is more positive than negative. Hence, the atom will become positively charged. Okay, it will become positively charged. Another scenario, guys, can be we can add an electron. Okay, we can add another electron. Now I'm adding 3 more electrons. So basically now in this situation we have 2 positive protons and 3 negative electrons. So the resultant charge of the atom is what? Negative. Okay, because there is more electrons which are negatively charged. Okay. We cannot, guys, we cannot remove or add a proton. Okay, we cannot do that, because we cannot remove a proton because there are strong forces that is holding the nucleus, which we call nuclear forces. Okay, unless we are trying to create an atomic bomb. Okay, through uranium. Okay, of which is you can break uh, the nucleus in that case. Okay, what is important to us, guys? Let me redraw this atomic structure again because I want to get to what is important to us as electricians or electrical engineers. Okay, here's my nucleus again. Okay, there's my nucleus. Okay, under normal circumstance, the number of proton will equals to the number of electrons. That is for a neutrally, that is an atom in a neutral state. Okay, so I see here I have 3 protons, so I'll have 3 electrons orbiting the the nucleus, and so in the first orbit I can only accommodate 2 electrons. You know that from N1, the formula to determine how much the formula to determine the number of electrons that each shell can hold is 2n to the power 2. Okay, where n is the number of is the number of the orbit. Let's say for the first orbit, if I'm going to use that formula, I can see that this shell can only accommodate 2 electrons. Okay, which is the K shell, if you still remember. Then the next shell, which is shell 2 or orbit number 2. Shell or orbit is the same thing, guys. Orbit 2, okay, this one can accommodate 8. Yeah, okay, because I'm talking of I'm having 3 protons, so I'm gonna have 3 electrons. So the last electrons it will be here, guys. That is where the last electrons are going to be. 3 protons, 3 neutrons. Okay, and okay, guys, the number of proton, which we call it the atomic number. The atomic number is the number of proton. It tells us what type of atom are we talking about. Okay, we know that for a hydrogen, there's only one proton. If the nucleus has one proton, we automatically know that is what? That is hydrogen. Okay, so guys, what is of importance to us as electrician is the electrons, is the electron that is orbiting in the last valence shell. Okay, in the last orbit, in the outer shell. The outer shell, we electricians, we are concerned about a electron that is in the last what, or in the outer shell, which we call that electron, we call it what, the valence valence electron. Okay, okay, these electrons, guys, that those electrons that are in the outer shell are the ones that are actually responsible for for us for electricity, for electrical effects. Okay, so when we define electricity, we say electricity is the movement of these valence electrons, or sometimes we call them what, free electrons, is the movement of free electrons or valence electrons in a specific direction through a material. Okay, based on that definition, we can see that, guys, electricity is the movement of electrons through a material in a specific direction. That is what electricity is. So the question now will arise, but what causes this movement of what? Of electrons. Okay, what causes this movement of electrons? Okay, there is a force that is behind that. That force, we call it indoni voltage. Voltage, guys, is the force that causes the movement of what? Free electrons. So that is what a voltage is. So basically, without voltage, we don't have electricity. That is why when the power is out, when it's load shedding, if you go and measure and test for voltage, you will see that in your multimeter, there is no voltage. Okay, there's nothing to cause the free electrons through the electrical wiring in your house to move, because the electrons, they move through wires. Okay, ideally silver is the best conductor. Okay, uh, they move through wires. Okay, it can also move through air, for example lightning, but you need a very high voltage in order to force those electrons to move through the air. Okay, that is why when we're talking of a lightning, we are talking of extremely high voltages, meaning more force. Okay, so if voltage, guys, is responsible for causing the movement of electrons in a specific direction, if voltage is the force that causes electrons to move. Okay, and then, guys, it brings, what is this movement of free electrons called? The movement of free electrons, the movement of as electrons, we call it Indoni, we call it the current flow. Current flow is the movement of electrons. Think of this as if I'm saying think of a voltage as a force, think of a current flow as what? Motion or what? Or velocity. Okay, velocity. In order for us to have motion, we must have a force. Then we will have motion. Okay, then we'll have movement. Hence, I'm saying now the movement of free electrons is what we call the current flow. Okay, obviously, guys, as the electrons are moving, there is something that is opposing this motion. That is what we call Indoni the resistance. Everything has what? A certain amount of what? Of resistance. It doesn't matter whether it is a conductor, uh, uh, everything, even air, even myself, I do have resistance to what? A resistance to Indoni a current flow. Okay, my body opposes the motion to current flow, but at a certain level. Okay, a resistance yona is the what? Opposition, or think of a resistance as nani? A friction. It opposes the movement of what? Of a current flow. Okay, based again, guys, on what I have just introduced to you, that electricity is the movement of free electrons through a material. Okay, so it means we must have a voltage, we must have current flowing, there will be obviously a certain amount of resistance for us to have what? Electricity. Okay, and in order for electricity to move, it has to move through something. Electricity cannot move in a vacuum. Okay, it has to move through something. Okay, then it brings me to the two types of materials that basically, let me say three types of materials that we'll be talking about in this course. Three types of electrical materials. The first one is what? The conductor. Okay, we can classify a material as a conductor if it allows current to flow through it easily. Okay, we can classify, think of, okay, before I move on, think of Indoni, a copper, a silver, a aluminium, a gold. Those are good conductors of electricity. It means that it can pass, this material can pass a current flow through them with ease. Okay, then another type of electrical material, that is Indoni, insulator. Okay, these ones, they block the flow of Indoni, a current, or they block the flow of electrons, the movement of free electrons. Insulators, think of a rubber, plastic, a paper. Okay, what we do actually need this material in order for to keep us safe, and in order for it for us for them to keep us safe, we need these materials to keep us safe from electricity, because we know that electricity can kill. Yeah. Okay, so if you are running a wire, a copper wire, you must insulate that wire so that if you touch, or you accidentally touch, or a baby or an infant accidentally touches the wire, they don't get electrocuted. Okay, then the last electrical material that we're gonna talk about, that is Indoni, semiconductor. This one, it's very, very important. It's what is driving the new industrial revolution, if you will call. Okay, this material can behave as this material can behave as a insulator or as a what conductor. Is basically two in one. Base, you can use this material as a conductor or as an insulator based on how you want to use it. Okay, now if you still remember, okay, guys, I talked about voltage, which is the force that is pushing or driving the electrons. And then I talked about current, which is actually the movement of free electrons. Then I talked about what? Resistance, which is the opposition, to the flow of free electron, or the opposition to the flow of a current. Okay. Now these three electrical quantities, this is what we'll be calculating for the entire course of electrical engineering. We'll be looking at voltage, current, resistance, and lastly, power. I haven't touched that yet. Those are the three important things that you be studying in for the entire course. I don't care whether you decide one day to go and do your master's. The things that you'll be learning about in electricity is voltage, current, resistance, and power. Full stop. Okay? That is what you'll be calculating. That is what you'll be, in fact, you'll be looking at these quantities to solve electrical problems or fix electrical faults. Okay? So there is a tool, guys. There's a very important tool that I'm going to touch on now. That tool is what we call Ohm's law. Ohm's law. This tool is what we call Ohm's law. Guys, this tool is very, very important. If you have to go and fix anything that is electrical, electronic component, power systems, anything electrical, you only fix it with what? Ohm's law. Okay, because Ohm's law will actually predict what is happening in a circuit. Okay, Ohm's law, okay, guys, it describes the relationship between voltage, current, and what? Resistance. Okay, it describes the relationship between voltage, current, and what? And resistance in a circuit. Okay, Ohm's law, nanko, I is equals to bani, V over R. Okay, according to Ohm's law, just by looking at this formula, yeah, this Ohm's law is very important. We can see that the current flowing in an electrical circuit is directly proportional to the voltage across the circuit, and it is inversely proportional to the resistance of the circuit. That is Obani, that is Ohm's law. Okay. So okay, guys, that's about it. This was just an introduction to what electricity. So as we study through, as we progress through, you'll see the only things that we are talking about in this entire course, that is voltage, current, resistance, and power. Okay, so that is what we'll be doing. And just like lastly, before before we conclude, we the important question that we're answering in this episode was, what is electricity? Electricity is the movement of free electrons through a material in a specific direction. If you mention by electricity is the movement of free electrons or the movement of current flow through a material. Okay, obviously for us to have that a movement, we need what? Voltage. And also a resistance is the opposition to indoni, to the current. Think of it as indoni, a friction. And there are three materials in electricity. We classify the materials in three categories, that is conductors, insulators, and semiconductors. So guys, when we meet again for another session, we'll be looking at basic electrical circuits. Okay, please stay tuned to the channel. Please guys, share the channel to your fellow students, and also like and subscribe to the channel. Thank you.